Hello, everyone, and welcome to my talk on transforming data to unlock its latent value. I'd like to start out here by asking you guys a few questions. So first, how many of you consider yourselves data scientists? Just raise your hand. Okay, great. How many of you spend a lot of time exploring data in your day-to-day work? Okay, excellent. Now, how many of you have a formal process or framework that you use specifically for data exploration? Perfect. So what I'd like to do in this talk is tell you a little bit about the process that I use for exploratory data analysis in my day-to-day work. And so for those of you, the few of you that already have a process of your own, my hope is that you see some similarities in our approaches and maybe take away a couple things that you can add to your own process. And for most of you who don't, what I hope is that you take away from this talk an intuitive, repeatable framework for analyzing, visualizing, and discovering insights from your data. But before I jump into that, I'd like to tell you a little bit about myself here. So that's me. I'm Tony Ojeda. I've been in the analytics space and more recently in the data science space for over a decade now. I'm the founder of District Data Labs, which is a data science education and research company based in Washington, D.C. And I got into data science from a business analytics and finance background, which is kind of where I acquired my quantitative skills, and then I taught myself how to program over the years in both R and Python. And so in the years that I've been in this field, I've worked with my fair share of analysts, data scientists, as well as students looking to learn data science. And I've noticed that particularly during the data exploration phase of their work, I often see them grasping at straws when it comes to their approach to finding insights in data. And so what I wanted to do was put this presentation together to help create a more structured path that people could follow so that they could view insight discovery as a problem, break that problem down into manageable components, and then start working towards a solution. And so in this talk, we're going to look at an example of a real data set. I'm going to introduce you to the framework that I use, and then I'm going to walk you through applying those concepts from that framework to that example data set. But before I jump right into that, I'd like to talk a little bit about how I think about data and provide a little bit of context. So data is essentially encoded information, and the world that we live in is a very complex web of it. Each of us has a ton of information and details floating around in our heads. There's constantly new information coming in, and things are constantly changing. And so as humans, we have this ability and this capacity to deal with all this complexity and all this information that we're constantly receiving. And the way that we do that is by putting things in order. We group things into categories, we create hierarchical classifications, taxonomies, ontologies, all of these things. And these things help to provide order and structure to the way we view the world around us, and they allow us to look at something, recognize the similarities it has to a group of other things, quickly identify some of its properties, and then be able to make some decisions about it. And in fact, if we think about it, a data set, all it really is just a slice of this complex information that somebody has put together to try to communicate something about this complex world to a human or to a machine. And so the fact that this ability is built into us is great, right? And we use it all the time without ever really thinking about it. And that includes, unfortunately, when we're analyzing our data. And so I wanted to put together a data exploration framework that leveraged this ability that we have and that would help us make better use of this ability in our data science workflows. And so here is the framework that I came up with. It's basically broken down into two phases. There's the prep phase first, and then the exploration phase that comes after that. And you can think of the prep phase kind of as a ritual. You can technically do the explore phase without it, but it's the prep phase that's going to allow you to do the exploration well. So I highly recommend that you do that. And I'm going to be walking through this framework here for the rest of the presentation. So the data set that I'm going to be applying this framework to today is the Environmental Protection Agency's fuel economy data set. And this is what it looks like after some light cleanup. I've also included the URL on here where you can get the data set yourself if you wanted to. And so The first step in the prep part of the framework is to identify a couple of things about our data. The first is going to be to identify the types of information that we have in the data set. And so taking a look at this data, there's a few of these types of information that are kind of obvious. They jump right out at us. There's vehicle attribute information, there's vehicle manufacturer information, engine information, fuel information, transmission information, that kind of stuff. There's also some other types of information that may not be so obvious. And so because we have the year that each of the vehicles was made, we should be able to see changes in the data over time. We also have relationship data in our data set, both in terms of the relationships between fields and relationships between entities in our data. And finally, because we have both time and relationship information in there, we can acquire information about how those relationships have changed over time. The next step here was to identify the actual entities that are in our data. And so what exactly do I mean by entities? When I refer to an entity, I'm talking about the individual analyzable units that are in a data set. And so in order to conduct analysis on the data, the entities must be distinguishable from one another, right? A human or a machine needs to be able to take a look at them and say, this is one, this is another, this is another. And finally, entities usually have a hierarchical structure where they're able to be aggregated into a system or a higher level entity that they belong to. And so let's take a look at some examples of entities that are in this particular data set here to kind of try to drive this concept home. So we're starting off at level 1 here, which is the most granular that we have. It's the year and the specific model of the vehicle. At level 2, we can aggregate that up to just the year and the model type, which is a little bit less granular. And from there, we have a few different directions that we can go. We can go the year and the vehicle class, the year and the make, or just strip away the year and just keep the model type. And then at level 4, if we want to continue going, we have just the vehicle classes, the years, or all the makes. And so to drive this home and make this a little clearer, here are some concrete examples of actual records that are in the data set. So at level 1, we're talking about a 2016 Ford Mustang 2.3 liter V4 engine, automatic transmission, rear wheel drive, right? So very detailed. At level 2, we're rolling that up to say, okay, all 2016 Ford Mustangs, and then so forth and so on up the hierarchy there. And again, doing this is important, and it'll help you think about all the different things that you can do to the data and the different ways that you can look at it later on. I see a lot of people that are new to data science that don't do this. They don't think like this, and so they miss things in the data that they really should be catching. So I hope that this example makes it a little bit clearer. The next step in the prep phase here is to review some transformation and some of the visualization methods that we have available to us so that they're fresh in our heads. And so first up, I have here the transformation methods. And so the first one I have listed here is filtering, which is basically taking the data set and making it smaller by either looking at less rows or less columns, or both. The next one is aggregation and disaggregation, and this is where you're changing the levels that we looked at before that you're analyzing the data at, getting either more or less granular. After that, we have pivoting, which is where you aggregate by more than one variable at a time, so along each of the axes. So the rows and the columns each have a variable, and then you look at some count or some average or something like that, and how those are grouped. And then the last one I have listed on here is graph transformations, which is where you link the entities you're analyzing by the things they have in common, and then you examine the connections between the entities and how they're related to each other. And so by transforming the data, you're altering the structure of it, right? Which lets you look at it from several different perspectives. And just like looking at anything else from a bunch of different perspectives, you're going to learn something new about it from every way that you look at it. And the awesome thing about this is that the number of ways that you can transform the data is only limited by your creativity, essentially. And so this, for me, is one of the most exciting things about working with data. All the different things that you can do to it and all the creative ways that you can transform it. In addition to transforming the data, I also like to go a step further and visualize it. Sometimes the transformations that you perform kind of in the earlier step can be kind of difficult to look at and interpret visually. And plotting them really allows you to pull in the human visual cortex into your analytical process and makes the insights really jump right out at you. And transformation and visualization really go hand in hand. Since there's a multitude of ways to transform data, there's also a multitude of ways to visualize it as well. And so here I've listed a few of these, and there'll be additional pictures later on in the presentation if you're not familiar with a few of these. All right, and so the last step in the prep phase is to create some additional categorical fields that are going to make our data easier to transform and explore later on. And we're going to do this in 3 ways. So the first way that we're going to do this is by identifying opportunities to create higher level categories out of the current categories that we have in our data. So I have an example up here. So imagine that you're aggregating by transmission. This data set has 44 unique categories for the transmission field. And so that's going to be tough to look at, and you're going to have to work really hard to find insights there. But if we take a look at the different categories that are in this, and we're able to find some things that they have in common, then we can make it a lot easier on ourselves. So in this case, the thing that all 44 values here have in common is that they either fall into an automatic transmission category or a manual transmission category. And so we've created a new field called transmission type that just has whether that record falls into one of those 2 categories. The same thing for the vehicle class. This is just another example. This one has 34 unique categories in that categorical variable field. And I was able to distill those down into 8 categories that are listed here on the slide. And so that makes things a little more manageable. And so keep in mind that you're not overwriting the original categories. You're just creating another categorical field that's allowing you to view the information at a higher level. And so if you need to drill down to get more granular categories, you can always do that. But at least after you do this, you actually have the option. The next way that we can create additional categories for ourselves is by binning some of the continuous variables and breaking them up into different categories based on how high or how low they are. There's multiple ways that you can do this, but I like to use quintiles because it gives me kind of one moderate category in the middle, and then 2 categories outside of that that are kind of moderately higher and lower, and then 2 other categories at the end that are kind of more extreme. And I just find that that's a very intuitive way to split things up. And so I've identified 4 fields in the data set here on the slide that we can do this for in the current data set. And then the final thing we're going to do in the prep phase here is cluster our data and create different categories out of the different clusters that result from that. And now there's a few reasons that I like to use clustering to create categories like this. The first is that it takes multiple fields into consideration together at the same time, whereas the other categorization approaches we were looking at earlier only consider one field at a time. It also creates new categories for you automatically, which is great because it saves time versus you having to comb through the data yourself, trying to identify any patterns and form categories based off of that. The third reason I like clustering is because it sometimes groups things in ways that you as a human may not have thought of yourself. And I'm a big fan of kind of humans and machines working together on stuff like this. But the question with clustering is always, well, how many clusters do I use? And the answer is usually, it depends. There's no real right answer for this. Now, that being said, I personally try to keep it to under 10 clusters when I'm doing this for creating categories, because otherwise it becomes too many categories for you to intuitively try to distinguish between. And And so I usually start out with about 8 or 10 clusters, and then I try to work my way down until I find some clear boundaries between the clusters. So you should be able to look at them and visually distinguish one from the other. And so starting out, that's going to look like this. So just from looking at this, you can tell that we probably have too many clusters here because clusters 3, 4, and 6 look a lot alike. Clusters 0 and 1 are also pretty close to each other, and clusters 2 and 5 also look a lot alike as well. And so just judging from the way this looks, I'm willing to bet that we can cut the number of clusters in half and get some better distinctions between each of the clusters. So let's go ahead and do that. And so now here we've reduced the number of clusters to 4, and now the clusters look a lot better, right? Clusters 0 and 1 look like polar opposites of each other. Cluster 2 looks like it's pretty well balanced all across the board, and cluster 3 looks like it's kind of halfway between cluster 0 and cluster 2. And so now that we have a good number of clusters, that's great, but it's kind of hard to remember what clusters 0, 1, 2, and 3 mean, right? And so the next thing I like to do is I like to assign some descriptive names to the clusters based on kind of how low or how high each of the values were in each of the boxes. So for our data set, I'm going to assign each of the clusters the names that I have on the slide here. And now we have these meaningful categories, and now our data is in really good shape, and that means that we can move on to the explore phase. So in the explore phase, we're first going to look at filtering and aggregation, and then we're going to look at the relationships between fields and then the relationships between entities. And we're going to look at these things visually, we're going to look at these things over time, and we're going to use them to discover insights in our data. And so here I filtered the data by year, so just for 2016, and I've aggregated it by vehicle category, which is one of the 8 categories that we created earlier. And so this is what the data transformation looks like, as well as the corresponding bar chart. And so from this we can see that small cars, there's significantly more of them than all the other types of vehicles. SUVs are kind of the next most popular, followed by the mid-sized cars. And so once you've done this, it's very easy to change out either the year or the category that you're aggregating on to get a different perspective on the data. So here I've changed out the year and aggregated on the same category. And so here you'll notice that SUVs didn't exist yet. Small cars were even more popular, and pickup trucks were as well. And so in addition to changing the year, as I mentioned, you can also change out the field that you're grouping on, right? So here, going back to 2016, here I've changed out the vehicle category for the engine size quintiles that we created earlier. Here's the fuel efficiency quintiles that we created earlier, and even our clusters. And this is great, but what if we wanted to take a look at the vehicle manufacturers? Let's say that we wanted to know how many models each manufacturer currently makes, or even which manufacturer currently makes the most, right? We can do that pretty easily as well. Just change out the make for whatever the category that you had in there was. And so here we can see that BMW currently has more models on the market than any other auto manufacturer, and by quite a bit, actually. Okay, so far we've been looking at the data at a pretty high level. We've been aggregating by a single categorical variable at a time. Next, we're going to go down a level and take a look at 2 or more variables at a time. And the way that we do that is with pivot tables. So here, I've created a pivot table heat map where you have a row for each fuel efficiency category and a column for each engine size category. And you can see how many vehicles fall into each combination of these. And just like we did earlier, we can slice by a different year and easily get a different perspective, right? So here's what the same heat map looks like for 1985, right? 2016, 1985. And with this approach, we're not just limited to 2 variables. We can have multiple variables for each of the axes, And it'll show us all the different combinations of values for those variables by whatever other variables we want. And so in this next heat map, I've basically doubled up on the rows. So we've got engine size and fuel efficiency combinations represented by the rows, and we've added a third variable, which is the vehicle category across each of the columns. And so now we can see a finer level of detail about what types of cars have what size engines and what level of fuel efficiency. We've added a little bit more complexity and a little bit more granularity to how we're viewing the data here. And so if we want to go back to analyzing the different auto manufacturers, what we can do is we can take a look at how the number of models they have on the market currently is distributed across all the different vehicle categories. And so that's exactly what I've done here. And now you can get a better sense of each auto company's current strategy in terms of the breadth versus the depth of vehicles that they currently offer. So it looks like BMW is doubling down on small cars, as is Porsche. Ford and Chevy and Nissan are going for breadth, right? They make vehicles in just about every category. Jeep and Land Rover are basically only creating SUVs. Ram's only creating pickup trucks, and so forth and so on. And so in addition to looking at these different aggregations and pivots visually at a given point in time, I also find it insightful to take a look at how they've changed over time. And so, for example, here are our vehicle categories just aggregated, but over time now. So we can see that small cars have generally dominated all across the board. We can see the introduction and increase in popularity of SUVs starting in the late 90s. And we can also see the gradual decline in popularity of pickup trucks, which is the blue line on the graph here. And if we wanted to, we can zoom in and do a filter for a specific manufacturer in order to see how their specific strategy has changed over the years. And so here's BMW's vehicle categories over time. You'll recall from a previous graph that they had a bunch of more vehicles than all the other companies currently, specifically in the small cars category. So here, we're able to see kind of the evolution of that, right? So they started off making a reasonable amount of small cars, and then sometime in the late 90s, they made a decision to increase the types of small cars that they make. And we can contrast that with a company like Toyota, where it's kind of the opposite. They started off making a bunch of small cars, and then they made a decision to make fewer and fewer of them over the years, instead shifting their focus to SUVs, pickup trucks, and mid-sized cars. All right, so the next step in the explore phase here is examining the relationships between fields in the data. So if we're looking at relationships between variables, I like to start off with a scatter matrix, which looks kind of like this. And this gives me a bird's eye view of the relationships between all the fields in my data set. So from this, we can see that there's some linear relationships and there's some more exponential ones in there as well. And this is great, but what's even better is that we can add another dimension of insight to this by overlaying a layer of color on top of this that represents one of our other categorical variables. And so here I've overlaid the clusters that we came up with earlier, and now we can see not only the relationships but also the different clusters and where their boundaries are and how much overlap there is from one cluster to the next. And once we've got this colorful bird's eye view, we can easily zoom in on anything that we think looks interesting. And so here I've zoomed in on the engine size versus the fuel efficiency to see kind of how those are related, and I've got the cluster overlay in here. And so you'll see kind of at the upper left here, you have your smaller, more efficient engine vehicles, and then in the blue, you've got your smaller, kind of more moderately efficient vehicles. In the red, you've got your mid-size, more balanced vehicles, and then at the bottom right, you've got your larger, less fuel-efficient cars. And we can do the same thing with the engine size and the fuel cost. So taking a look here at a more linear relationship with the clusters, and you kind of see the cluster boundaries on here as well, this time going from the bottom left up to the upper right. And again, you can do this for any combination of variables that you have in the data set. These were just a couple of examples. All right, so the third step in our explore phase here is examining the relationships between the entities in our data. And the way that we're going to do that is through graph analysis. So as I said before, graph analysis is going to allow us to explore relationships between these entities. And these relationships are usually based on attributes that the entities have in common or actions that one entity takes that involves another. And so the entities we're going to be analyzing here in this example are the auto manufacturers again. And in this case, the attributes that they have in common are going to be the vehicles that have similar attributes to each other. So we're going to examine how the different manufacturers relate to each other and how those relationships have changed over time as well. In order to do this, we're going to have to transform our data set again from the relational form it's currently in here into graph form. And that looks kind of like this. So we have two different companies as make X and make Y, and then we have an edge weight. And this edge weight tells us how many vehicles with similar attributes the two companies have in common. So the more vehicles with similar attributes they have in common, the more alike the two companies are, and the stronger their connection is going to be. And so looking at the data in this format, you might say, well, there's not much to this, and you're right. But having it formatted like this lets you create really interesting things like this. So this is a network visualization showing the relationships of all the different vehicle manufacturers to each other. And from taking a look at this, we can see, for example, that the companies that make the most types of vehicles across the most number of categories are positioned towards the center of the network here. And that's because they're going to have more in common with other companies just as a result of the depth and the breadth of their offerings. You can contrast that with the companies that have more specialized offerings like Ram at the very top there or Land Rover at the bottom. These companies make only one kind of vehicle, so they have less connections and they're positioned near kind of the edges of the network. And so this is great, but looking at all this at once does kind of make it look a little cluttered. So what I usually like to do from here is try to filter down and look at an ego graph for a specific auto manufacturer. So here we have an ego graph for Nissan, and you can basically see here that they're now at the center of the network, and you can also see all the other companies that they have vehicles in common with and how they're connected to each other. So that's an interesting way to kind of zoom in and view on a graph. Another thing that you can do with graphs is community detection. And so I took our original graph and I ran it through a community detection algorithm, and it was able to find 4 communities in our graph. And what I've done here is I've basically color-coded the nodes in the graph by the community that they belong to. And then you've probably guessed what's coming up next, and that's taking a look at how the connections in our graph have changed over time. So here I have a line graph that shows the number of edges or connections for each of the manufacturers. And when you have a lot of nodes in the graph, this tends to look a bit cluttered as well. But as we did before, we can always fix this by zooming in and being able to filter on a specific make that we're interested in. And that's exactly what I've done here. So here I've chosen just a handful of companies, and now we can see more clearly how each of their connections have changed over time, how they started off kind of spread out and they've converged over time. All right, so we've done a lot to this data set using just a few concepts, and so let's do a quick recap. Here's an image of the framework again. So we started off with the prep phase. We identified the types of information that were in our data set. We identified the entities that were in our data set as well, and then we did a review of all the different transformation and visualization things that we could do to our data set. From there, we created additional categories that were going to help us down in the explore phase. So we did that through category aggregations, through binning our continuous variables, and through clustering. And then we moved on to the explore phase, where we started with the filtering and the aggregating, and then we looked at field relationships, and then we looked at the relationships between entities here at the end. And we did these things visually, and we did these things over time. And what we end up with at the end of the day is so many insights, right? I mean, just in the short amount of time that we've been looking at this data set, look at all the things that we've discovered, right? About 1 insight per minute on average, which is pretty good. And so I hope that you found this talk interesting, and I hope that you've learned a few things today that you can take back with you and implement into your own workflow. So thank you very much for coming to my talk, and here's all my contact info, and there's a link at the bottom here to the code as well if you're interested in that. So please reach out. I would love to hear from you. Thanks a lot.
Very nicely done. Thanks a lot for that.
Thank you.
We have about 9-10 minutes for Q&A, so if anybody has any questions, we'd like to hear them. Hands up somewhere, and I'll give you the microphone. All right, right in the middle. I like it.
Hi. So I guess I think this is really cool, but something that I'm kind of confused about is how
Sure.
do you tie all of this I guess process into like a prediction workflow where you're trying to predict something in your data?
Yeah. So the way that I usually do it is I use some of the categories that we created during the prep phase as like features, let's say, for like a machine learning algorithm to learn off of. And sometimes that makes it easier versus it having to figure out all the continuous variables and that kind of stuff. There may also be ways that you can change entities or instances that you're feeding into the algorithm, and at, let's say, a higher hierarchical level, you may be able to predict more accurately than kind of down at a more granular. So yeah, those are just kind of a couple ways that come to mind that you can kind of implement this into a predictive analytics process.
I enjoyed the talk as well. I thought the framework looked really good. I was curious in your prep phase about, with the data you had, it was pretty clean, obviously, but in the real world, we get a lot of noisy, dirty data. So I was wanting to hear your thoughts about quality assessment of the data. How do you judge whether the data is even good enough to go any further in your process of exploratory? And also cleanup sort of approaches that you found useful.
Yeah, so the data set that I put up on the slide had kind of already gone through a cleaning phase. There was a lot more columns and like missing data and all this kind of stuff. So I cleaned that up kind of for the purposes of being able to present it. And so that's kind of one thing that you could do, right? Yeah, like not every aspect of the framework is going to be applicable to every data set. Like if you don't have time in the data, you can't do any of the time stuff, right? And so yeah, it just kind of depends on the cards that you're dealt in terms of the data set that you're working with, how deep into the framework and how many things in the framework you can actually apply to it. But at least with the framework, you kind of have a list of things and some checkboxes that you can check to say, okay, I'm going to start with this. Can I do this? Yes or no? If no, then okay, I'm going to move on to this step, and then so forth and so on. So, yeah, you got a question over here?
Okay, I have a quick question.
Sure.
So let's say you start with a bunch of source dirty data, a bunch of it, and the end goal is to develop an enterprise data warehouse. How would you go through this data profiling process to go from a bunch of source data to find out what you've got, to clean it, to end up with a good data warehouse at the end?
Yeah, so going through kind of this framework is going to really let you get to know your data because of all the steps that you're taking to it, all the steps that you're taking with it, and all the things that you're doing with it. So each step that you take is a different kind of perspective on the data, And so you learn a little bit more about it when you're creating the additional categories, when you're doing the clustering, when you're taking a look at it over time, when you're aggregating it up all kinds of different ways. So I would use those to kind of inform kind of how you end up putting the data together if you're just starting with like a huge mess of data, essentially.
Is there a step in there where you see where the dirty data is and it shows up really nicely and cleanly as there's the problems that I've got?
Well, it's tough to answer that question because each data set that you encounter initially is going to be completely different from the next one, right? And so, yeah, there's no real like common way. How you clean the data up is just a matter of what's wrong with the data to begin with, right? And so, yeah, there's no real like framework that I know specifically for like cleaning it up, let's say. Any other questions?
So I found the different ways of handling categorical data pretty interesting. It looked like a really good idea to, for example, group all the automatic and the manual transmissions together. Mm-hmm. That seems like something, though, that's probably easier when you have a smaller number of categories. Do you have any rules of thumb or tips for if you have more categories where it's not as obvious that, hey, there's a bunch of these that happen to be automatic, there's a bunch that happen to be manual, let's split them up?
Yeah, there were some other fields in the data that had a lot of categories that we just couldn't do that with, right? And so it's going to really depend on the meaning of the data in that field and the categories in that field. In some cases, they're going to be able to be aggregated further, and in other cases, like, you're not going to be able to know enough about each of the categories to be able to do that. And that's just kind of a reality of having to work with data, right?
How did you come up with the edge weights?
So the edge weights were, I basically copied the table over, and then I joined on vehicle attributes, and wherever they matched, however many per each pair of auto manufacturers matched, that was the edge weight.
So I think that's all we have time for today. I'd like to get another round of applause and gratitude for Tony Ojeda.
Thank you very much, guys.